What is Euclidean geometry? Have you ever wondered how we understand shapes and spaces in our world? The answer lies in a fascinating system called Euclidean geometry. This system was developed by the ancient Greek mathematician Euclid, who lived around 300 years before the Common Era. His work laid the groundwork for how we study points, lines, angles, and shapes in flat, two-dimensional spaces, which we refer to as the Euclidean plane. Euclid's most famous contribution is his book titled Elements. This influential text is one of the most significant works in the history of mathematics. In Elements, Euclid presents a series of basic assumptions known as axioms or postulates. These are simple truths that seem obvious, like the idea that a straight line can be drawn between any two points. From these axioms, Euclid logically deduced many other geometric truths, which we call theorems, using rigorous proofs. One of the key axioms in Euclidean geometry is known as the parallel postulate. This postulate states that, through a point naught on a given line, there is exactly one line that can be drawn parallel to the original line. This particular axiom is what sets Euclidean geometry apart from other types of geometry. Euclid's work begins with plane geometry, focusing on flat surfaces, and then moves on to solid geometry, which examines three-dimensional shapes. Interestingly, Euclid also touched on concepts that we now associate with algebra and number theory, but he explained them through geometric ideas. For over 2,000 years, Euclidean geometry was viewed as the only true geometry because its axioms appeared to be self-evident. From a European historical perspective, Euclidean geometry represents a foundational achievement in the intellectual tradition of ancient Greece. It has influenced not only mathematics but also philosophy and science throughout European history. The logical reasoning and proof methods established by Euclid became central to the development of Western scientific thought. While Euclidean geometry dominated for centuries, the 19th century brought forth the discovery of non-Euclidean geometries. These new systems challenged the universality of Euclid's postulates, showing that alternative, consistent geometries could exist if the parallel postulate were modified. Moreover, modern physics, especially Albert Einstein's theory of general relativity, revealed that the physical space we inhabit is not strictly Euclidean, as it is curved by gravity. Despite these developments, Euclidean geometry remains a fundamental part of mathematics education today. It is widely used in practical applications such as engineering, architecture, and navigation. The clear and logical framework that Euclidean geometry provides helps us understand space and shapes in our everyday lives. So, the next time you think about geometry, remember Euclid and his lasting impact on how we perceive the world around us.